were moved to Puerto Rico in 2013. As recent studies has shown by Dr. Stacy Williams, it has covered more than 50% of the coral reefs that are very interested for us to do the restoration work. Okay. And why could this be a problem? Not much known about this algae, its distribution and the ecological impacts on the reef processes. And we got so many questions like, does it grow on corals or on the live coral tissues, or uh, we have seen things in the wild like that it creates some types of canopies, like they're hollow inside, and they may obstruct sunlight and interfere with coral recruitment. It may be out competing corals for substrate and reducing biodiversity in the reef, making it a little bit homogeneous. Okay. This algae seems to be affecting corals like Acropora cervicornis, which is our main target of restoration efforts. So this is very important to know how this behavior is working. It can lower reef benthic habitat heterogeneity, and it lowers or impedes coral larva recruitment as it was recently studied by. We think that this paper says that it doesn't have or it has very little of the microbiota that lives in the pack algae that helps corals settle on them, right? It also may impede reef's natural regeneration ability, making it less resilient, therefore making it more vulnerable to hurricanes and other disturbances. So we embark in the task of knowing how this coral, the Acropora cervicornis, behaves in the presence of Ramicrusta textilis. And by that, we constructed these table-like structures where we place these wire mesh grids into which we attach corals and the algae in different concentrations. As you can see here by my graphic design degree, we did various type of treatment where we just put 5 corals in no presence of Ramicrusta textilis. We made it and put it in presence of 25% cover of Ramicrusta textilis and in 50% area cover of Ramicrusta textilis. We also took 2 different sizes, being large and small, where small it was 10 centimeters or less, and large would be 10 to 15 centimeters. And then we use a very old, reliable, low cost, efficient method that is just taking the tape measuring to see its growth rate. And we did this for a period of 15 months. So what we found? This temporal trajectory shows that during the first times that we measured the algae, it was growing, measured the coral, I'm sorry, it was growing, but right after the middle, by T4, T6, we had a natural disturbance being a bloom of cyanobacteria and golden noodle algae that affected the growth, but right after that, the measures that we did, it kept on growing. And this is true for the small size and the larger size. When we did the statistics, we found out that there is a significant difference between Ramicrusta textilis, the fragments are in presence of Ramicrusta textilis at 50% area cover, and the control ones. Showing here that the controls, the Ramicrusta, at the Acroporids at Ramicrusta textilis 50 in presence of Ramicrusta textilis at 50% grew faster than the control ones, contradicting what we thought that would happen. Right? When we take size into consideration, we found that there is also a statistic difference, being the large corals that grew way faster than the small corals. So, in conclusion, Ramicrusta textilis did not evidence colony overgrowth on coral live tissue, and this might suggest that it takes advantage of coral mortality to colonize open substrate. And this picture here is very interesting because we had just one case where the algae the talus of the algae just grew right right above the coral. Picture quality couldn't get it that well, so it doesn't it doesn't touch the coral, the live tissue of the coral, but we think that it might block the sun and might kill it that way. So Acropora cervicornis growth rates were higher in presence of 50% area cover of Ramicrusta textili, which might suggest that some of the initial response to avoid potential interference or out competition mechanism of sunlight obstructed by the algae. Larger colonies had a higher growth rate in comparison to small ones. Also, Ramicrusta textilis appears to have an effect of interference and out competition, that's blocking the sunlight, as I showed you before, combined with a strong disturbance and preoccupation ability on dead coral surfaces. The coral appeared to be responding to a competition effect in presence of large amount of this algae by increasing its growth rate. But rapid substrate and colonization by Ramicrusta textilis in combination with a low Acropora cervicornis abundance and narrow spatial distribution results in a double jeopardy for coral conservation. Yeah. So I would like to thank all these beautiful people of Sociedad Ambiente Marino that it wouldn't be possible for me to have done this without them. And do you have any questions? Yes. Well, that is a really good question. I think that the only thing that they have found out that eat the Ramicrusta textilis is Diadema antillarum and nothing else. So probably it could deter everything else that is not Diadema antillarum.
Other questions? We have plenty of time for questions.
Yes.
I just want to say this is really important work, and thank you for doing that study because we just don't know a lot about the ecology of this organism that I think is an incredible threat to all these reef restoration efforts.
Thanks.
And just to follow up a little comment on that last question, we've done some metabolomics-based work on Ramicrusta that's coming out in a few weeks, and I'm going to talk about it at 3:07 p.m. And it produces a ton of caffeine, which is not produced by some of the corals and soft corals we looked at. So that could be a predator avoidance mechanism. A lot of land plants use that.
Oh, wow. Thank you.
Other questions?
Oh, yes.
You might have mentioned it and I might have missed it, but how did you actually attach the Ramicrusta to the grids that you suspended at the nursery? Were the grids seeded with the algae or were they zip tied on?
Sip that on very carefully because the algae is like, the consistency is like cornflakes is the best way I can, or a cookie. It crumbles very easily, so we have to be very careful zip tying it to the grid. Yeah, thanks. Yes.
Did you notice anything through the process of the study that would give you an inclination as to methods to prevent negative interaction?
Between the coral and the algae?
Yes.
Let me think. Well, I think the problem really is that interactions is negative when there is talking about recruitment, because I know it doesn't recruit on Ramicrusta textilis. So the only method would be to increase the predators of this algae so we can have more substrate available for recruitment. In terms of transplant, you can actually transplant it. This helps an argument of a paper that we did a while ago that says that if you transplant bigger corals, it's better for the survival rate. So this is also true in presence of Ramicrusta. So basically, just there's a good project by Dr. Stacey Williams that you can transplant diadema on the reef right before you do the coral transplant. It'll help just graze that algae. Nice.
Other questions?
Thank you very much.